Hello, everybody. Glad to be here. So let's today we'll have a more in-depth than usual look at how we actually hire people, and in particular what we do at Algorithmic sections, how they work, and etc. A little bit about me. So I'm not new to algorithm. So I've been organizing sports programming competitions for more than 25 years. So I kind of in touch with very advanced algorithms that's of the kind you wouldn't usually find in production. And I've also been working for financial technologies for many years, doing various high-load systems, trading systems, and I was leading Kotlin project at JetBrains for many years. But today I am in charge of developer experience at Yandex Urban Services. We do maintain all the various tools that are specific to urban services that developers and our business groups use. And I also participate in, of course, in hiring and policies and how do we hire and why we hire, why we select for certain skills. So you're going to hear what and why we do from the source. So to set some expectations, I'll structure my talk like this. So I'll first talk about why we do algorithmic sessions, then I'll debunk some very popular myths about them that's very common online. Then we'll talk about what we actually look for, like what are skills we're looking for in candidates when we select them. Then I'll stick with me, there will be technical part of the talk where we'll actually take a problem and we'll walk you through and what we expect the candidate to do on this section when they try to solve it, and I'll give you some practical advice of what skills and what things you can do to improve your skills and your hiring perspective. I also told you that I'm part of Urban Services at Yandex. That's one of the largest parts of Yandex. I mean, it's very high-loaded parts, and that's kind of sets the important context of all the things we do in our business group, because every small service we do often comes with very high load because we serve tens of millions of users, and the whole architecture is very big with thousands of microservices running it. So for us, we value certain engineering skills because our business required us to, so not because we chose to. Like that's comes with the scale at which we operate. And it's kind of, when you start reading online about Yandex, it's kind of these algorithmic trading sessions, as they're known. I mean, they put a kind of very high bar that we very consciously maintain. So what we do is we give our candidates an hour, we give them text editor. It doesn't have autocomplete, we don't use compiler, I mean there's only syntax highlighting, and what we ask you to do, we ask you to solve the problem. What we look at the logic of your solution, not the small minor details that compiler will catch. So we do understand that in real life, you're going to have a compiler at your site. The compiler will flag and find the errors. So we're not interested about that. We're interested about the logics of your code. How can you do it? And this hiring section is not actually called algorithmic internally. We don't call it that way. So that's kind of an external word that is misleadingly attached to the section. It's a standard. Every engineer who we hire has to pass it. There are no exceptions. And it's standardized, so it doesn't matter which part of Yandex you apply to, who interviews you, like you all get judged over using the same common engineering standard. And so let's clear up some misconceptions. I mean, even though the people call it algorithmic sections, it has nothing to do with algorithms. I mean, it doesn't require you to know any of the algorithms. I mean, we don't ask you about graph algorithms. I mean, not even the trivial ones like Dijkstra's shortcut path. We don't go into string algorithms. You don't even require to know basics like this. You study in first university course like Knut Morris Pratt. None of that happens there. We don't require you to knowledge any fancy data structures. Like I mean, all you have to know is how to use like hash maps and list, nothing fancier, not even like segmented trees, like quite basic ones. And we don't require to be able to re-implement any of the standard library primitives. I mean, if you can allow it to pick any programming language you want, and you're free to use whatever standard utilities it has. So you don't have to re-implement your hash map, you don't have to re-implement your list. Like, you don't need to do any of that. And so that's why, I mean, calling it algorithmic sections kind of really just confuses people who are trying to apply to Yandex. I mean, because, I mean, you don't have to memorize algorithm. It's not about that at all. So what it is about? So what we're really testing? This section is about looking how you solve problems, how you approach a problem that's loosely specified, how you ask the right questions about the problem, how you acquire corner cases, and how you translate those fuzzy requirements into precise solutions. Because that's what we do at our job. That's what every software engineer does. You know, business at our workplace always comes with, and happens in every business, comes with some non-clearly spelled out requirements. It's our job as software engineers to figure out what are actual engineering constraints, what are actual bottlenecks, what are actual corner cases, and turn it into precisely implemented software. And so that's exactly what we test, how we are good at this specific job as a job of software engineer. It's very important that the part of this section is you ask about, we look at how you reason about performance. That's also an important part of this whole sections. So we see that you can figure out what's the asymptotic complexity of your approach. We see that you can reason about how much extra memory it requires. Why? Because, I mean, we only interest in engineers who can pose and answer those questions, because our systems work at very high load. I mean, we don't want to figure out in production or in testing that your system crashes under load, because like discovering it in testing or in production is just too late. You've already wasted too much time. We're looking for engineers who think about the things at the moment they write code, not post factum, because we want the fastest path from business idea to working production code. And that comes, especially at our business groups. I mean, that comes about almost every problem we solve or attempt to solve. So this has to be your second nature reason about performance. And that's the kind of candidate we're looking for. And it's also about whether you can write code that others can trust. So we're not, I mean, the key is, it's what we do. I mean, some people confuse our sections with lead code. And if you're familiar, who is familiar with lead code? Who went to lead code and solve problem? Okay, so what you do at lead code, I mean, they give you a problem, you write solution, boom, it says accepted or rejected. Nobody cares about what kind of code you wrote. I mean, we're not doing lead code at Yandex because we do care about the code you wrote, because, I mean, that's important and the software engineers work. So what kind of, can you turn your idea into the code that's actually easy to understand, that's actually readable, that clearly translates your idea, that actually communicates intent on your code. So when I look at your code, then I'm as an interviewer, I should be able to immediately understand what it does. If I struggle to understand your code, then I'm going to reduce your marks on the interview, because I mean, we're looking for engineers who are capable of writing for the team, because you write it once, but then dozens of other people will read over your code. And I mean, we're only interested in hiring people who can write it clearly. Because, I mean, all we do is teamwork. I mean, we never have like single person projects in our company. Everything we do is teamwork, and only teamwork. And the other thing we test for is actually the most underrated, but the most important skill of software engineering is actually the skill of reading the code. Because the fact is, at your job, most of the time you will not be writing code. Most of the time you will be reading the code others wrote. It starts like from the moment you get hired and from your onboarding process. Because you onboarded into a new team, you get faced with some huge existing system, and you have to figure out what it does, why it's for. And that's going to be most of your work time as a software engineer in a big company, reading somebody else's code. And you'll be also reviewing other people's work. You'll at one point, maybe not immediately after you get hired, but at one point in your career, you'll be responsible of reviewing code that other engineers wrote. And we are looking at engineers who have a skill of reading others' code, who can look at the code and understand what it does, what are potential bugs there, or where it can adjust by reading the code. We're not interested in engineers who need to run the code to understand where bugs in it. That's why when people say, can I run this code? No, you can't on the interview, because like I'm not looking for an engineer who can figure out if the code has a problem after the code is run. I'm looking for an engineer who can read the code and spot the logical mistakes in it. That's kind of engineers we need as a company. So that's why we test this in this hiring section. And of course, we don't give you somebody else's code in the interview. They actually, turns out for many people, the hard part is just reading their own code and figure out the problem is. So that's a very important part of the interview. After you wrote the problem, you have to read it over and figure out if it works or not. So what are some red flags that almost immediately get people disqualified on the interview? So first red flag is by patch-driven coding, where people just look at the special cases, look at tests, and try to somehow patch those special cases into their code. Those kinds of people usually never pass the interview. The other red flag is with people, when they look at the code and try to see if it works, they kind of just debug it step by step in their mind. And that's basically the only way they verify it correct. I mean, it's okay if it's this additional approach to verification, but that's the only approach they rely to see if the code works or not. It won't scale to real production. We don't want those people to get hired. And I've already mentioned, I mean, if a person can't review if code is correct without running it, that's definitely a no-go. I mean, we can't afford spending time that's, every person with every pull request will be running it. I mean, it's not how it works. We don't want to hire people like that. That's like really big red flags when we hire. So what we actually looking for? I mean, the key traits we're looking for is whether a person is able to spot edge cases and identify key invariants in the problem they solve. So that way they can implement the code with confidence that it actually works. So the correctness, write the code in a way where correctness is not an afterthought, but it's the end result of their logical thinking process, where they have looked at the problem, they've identified how they has to structure the code, so like the code is absolutely necessarily works without exceptions, or if there are exceptions, they clearly identify them, and then implement this in code. That's kind of people we're working for. That's kind of engineers we really need to make our software scale and handle the loss of tens of millions of users in the real life. So that's kind of basics of what we look for. So now let's do the walk. Let's, instead of just talking in abstract, let's take a concrete problem and walk over it. Some disclaimers are important here. First of all, I've just looked at lead code and I've picked a problem that we don't actually give, but it's kind of similar in spirit to kind of problems we could give. We only give usually two problems. First is a little bit simpler than the second one, and this one that I found is kind of its complexity is usually in between. I mean, it's usually this problem we'll look at. It's more complex than our first problem, but it's less complex than our second problem usually. So it's be good representative examples of the kind of problem we talk. But of course, we're not on lead code, so I'll show you like the logical thinking process that we expect the candidates to go through if they were faced with the problem like this. And this particular lead code problem is just good example in style, in size, and everything. But again, a reminder, even though we're using lead code as an example here, just because it's open repository of problems, we don't do lead code problems at the actual interview, and we don't test your skills in the way lead code does. I mean, as I told you, our approach is a little bit different. We'll look at how you think, how you reason about the problem, not whether you'll be able to get your problem to like code that compiles and produces correct answers. So let's take the problem. So the problem statement is this. Your friend is typing their name into a keyboard. And sometimes when typing a character, the key gets long pressed. So instead of once, the key gets pressed several times. And you have to write a function with two parameters that takes a name and what was typed, and returns true if it could have been typed this way by long pressing some letters, or false if not. And as usual, like when we give a problem, we give examples, and that they always come as a part of it. The example here is this. So for example, if name was Alex and the type string was AALEX, then the function should return true, because in this case, you could long press, double press A, then press L, then double press E, then press X, and it's going to be correct. The other example we might give is like if the name was Said and the type it was SSAA1EDD, then the function should return false, because you see in the original name, E was twice, but I mean, the problem statement says that character gets typed one or more times. So, I mean, you couldn't end up with just one E in the type, so the result should be false. And immediately as you see the problem, I mean, the first thing you're expected to do is actually go over cases, go over problem statement, make sure you understand all parts, and make sure you identify also missing cases. Because, I mean, there are just some examples. It's not these examples that we usually give with the problem, I mean, they represent some cases. They never represent everything. And at this point, you'll have to make sure you understand the fact, for example, all these examples were only see letters typed twice. It doesn't mean your code has to support that, because problem statement clearly says that can be pressed one or more times, but it's only twice in the examples. And this good part to make sure you really understand what problem you are solving, so you're not just solving for the specific test cases where they only happen twice, but more general problem. And it's okay at this point to ask your interviewer, like, do you understand correctly if, like, for example, input name is A and the type string is A 3 times, it should return true. Yes, it should return true, because we're solving more general problem, not just trying to patch around specific cases that were presented. That's very important. And it's, again, not just in problem solving, but in writing the actual business code. It should be generic, not specific to whatever examples you're thinking about right now. So how do we then reason about this problem? So the next step is actually taking and starting to reason. And the key to reason is also is trying to define some invariants that must hold, or some properties that's true about the code. So in this case, there's many ways to get this problem wrong, and a few ways to write a correct solution. And one of them is this. First of all, notice, let's look at the characters that were typed. And every character that was typed must be legal. It has to come somewhere. And there's actually just two cases on how a typed character could be legal. It's either matches next character from the name. So I can, for example, if my name was Alex, and then I can type the first A legally, the first typed A is legal because it comes from the name I'm currently looking at. It comes from name Alex. So we consume it, and we can consume the character from name and move to the next type character to see if this character is legal. In the case of double ALEX, we also get A. But it's also legal because that's repeat of previously typed characters, because the problem says that my friend sometimes typed the character multiple times. It means that every character in every type character could be just a repeat of previous one. In this case, it would be also legal. So that's one observation we make when we analyze the problem and where the type characters can come from. The second observation we make is that it's always okay to eager advance through name. I mean, the same typed sequence could have been produced in different ways. Like if your name, like Said, contained double E, and you type, for example, E multiple times, I mean, you could have typed it different ways. You can long press first T several times. You can long press the second T multiple times. But they're all kind of the same, right? We can always think about that. Okay, let's eagerly consume. Let's the first T just type once, and the second T type once, and then there are others E. Okay, so we'll assume this second E was double type. It doesn't matter if, in fact, like for this problem, it doesn't matter if, in fact, the first E was type made, was the second one. The result is the same. So we can, whenever we see character that could have been typed by pressing a character, we'll just always eagerly consume it. So and these two observations are basically enough to kind of, and actually that's what the interviewer looks at. So when the interviewer asks you, I mean, that's after you figure out what to do, the problem, how to solve it, there comes a moment where interviewer asks you to explain your solution. So you can explain the solution to him or to her and tell, you know, then you discuss with them how much time and memory the solution consumes. And at this moment, the key and what good candidates do, they explain the logic of their solution. They explain what invariants they have identified and how you're going to approach. The bad candidates, they try to explain the code they're going to write. They try to explain, oh, we'll have this variable, we'll do this, we'll this increment it here. That's not, we look at this place. I mean, we're not moved to the code. We're looking whether you're able to explain your ideas with just text, not with code. Because in real life, when you face a real production problem, there will be lots of code, hundreds of lines, thousands of lines you'll be writing, and there's no way, we want you to end up explaining to your colleagues like this code line by line. We want you to be able to communicate your ideas that are like why it's correct, not like going through every line of your code you're about to write. So this moment we expect you to explain this logic, and then interviewer will allow you to actually write the code. And now you go to write the code. And your challenge at this point is now actually translating the idea you have into the actual working code. How we do this? The right way to do it is to make sure that code reflects your ideas. So because we in this problem, we've decided that we'll look at every type character and see if it's correct or not, then our main structure of the code is going to be looped over type characters. By writing this as a for loop, like this is in C++, but I mean, there's kind of in any other language, we make it explicit in the code our intent to look at every type character. I mean, this code structure make our idea, I mean, you could have write while loop, yes, and some people do, but like if your intent is to look at every character, you shouldn't have written while loop, you should write for loop, because that represents your intent in code in the most direct way. Then again, if you will be creating some variables to track your state. And again, it's very important for you to think logically about what invariants they cover and what states they present. For this solution, in addition to the loop over type characters, we'll need the I variable that tracks how many characters we've already consumed from name. And this actually, some people, why it's important to think logically about the variable invariance, like spelling you might. I is going to be number of characters consumed, because some people, when they mess with it, they start doing one-off mistakes. I mean, at one point they decide it's going to count the character, and at the other point they decide it's going to count something else, and then, I mean, with different assumptions, different pieces in their code, it doesn't work. So think clearly about which. And actually, for this specific problem, we get to exploit the beauty of zero indexing in arrays. Because if I tracks the number of characters we already consumed from the name, then automatically means that character with index I is going to be the character we yet about to consume. When I is 0, we have not consumed any character. 0 index character is the first one we're about to consume. So, but again, I mean, just make it clear. I mean, some people mess at this point and their code start writing random +1 or -1 around the code. I mean, they had hard time then, you know, getting the code with the correct logic. So that's the key here. Invariance and the structure representing what you do. Now, what you do inside the loop? remember, we've identified that we're going to have two cases where we accept. So because there are two cases, we write if. Our first case, if the typed character is the next character from name, we're going to consume it. Well, because we track in I how many characters we consumed from name, we're just advance I++ to consume the character. And it's important thing here is not to forget to actually check if E is still, if we still basically have characters. That's very important edge case that some people might miss. And the common mistake for this problem will be just people missing this check to check if they compute and then they get out of bounds. And again, thinking logically about software is always about edge cases. Like, and this is edge case. We could have already consumed everything from name. We shouldn't have forgotten to check for it. And of course, the check has come first in the check. And when a person who gets interviewed notices a problem and then puts the check after the equals comparison, that's almost immediately disqualifies such a person from software engineering profession, because this means, they don't understand how actual code works. And understanding how code works is critical. Then, again, we've identified the second criteria is a repeat. So, and what's a valid repeat? So valid repeat if a type character is the same as the previous one, right? And it's, okay, again, not forgetting about edge cases is when j is above 0 and, previously typed character is the same as this one. But we have to check if it's not correct, because if it's not correct, we want to bail out. There's no reason to scan further. We can just bail out. So, good software engineer has to be really friends with logic, and like inversing this condition into the actual if should be a second nature for a person who is really a software engineer, because all we do is basically logic. And of course, you could write it differently. You can, instead of returning immediately, you can create like Boolean okay or not okay, set it that, it's false, and then check it later. That also works. The solution will be correct. It's just not as clear and does not represent the intent as clear, because, why waste time scanning, the answer further if we immediately see that this letter could not have been typed, and we can immediately return false. That's, again, efficiency. Like, if you already know there's no answer, like there's no need to waste CPU cycles to look further. And of course, the final check, after the loop, we have to check that if we've actually consumed all the letters from name, because our goal was if this name could have been typed in the way. So it's not just about legally typing every character, it's also about making sure that all characters from name were typed. And that's last return check just exactly captures this part of the logic. And so if you follow this logical argument, you'll end up with like solution like this. Like there'll be one function that has clear loop structure that represents, clear spells your cases you've identified, conditions. That's going to be kind of code you're going to write. And there are some bonus things to notice here. Like, for example, if you write std string, this kind of indicate you're not just using C++ for solving problems, so you're actually proficient in C++, and you know how your production code is written in C++. And why it's repeated on the left side twice, that's topping the slides. I wanted to say on the other point that's also the bonus point for using size t, because the size in C++ returns size t. So if you know that and you kind of in habit of matching the types, that's also good. But in fact, we don't give you any bonus points for any of that in this interview. So this interview is just about logics. So even though like interviewer might, mentally praise you for being a great engineer of knowing to write std and using size t, it's not going to actually earn you extra marks, because this whole section is about you thinking logically, not about you having expert knowledge of. It's not a section that's designed like to test your expertise in C++. So at the end, what we're looking for when we're hiring, we're looking for people who can solve problems, who think logically. So we can looking for people who, when faced with the problem, are not going just to patch it around, but are going to think logically about the problem, identify invariants, identify edge cases, and implement it. And we're also looking at people who are skilled at reading code. And that's a very important part of you because, again, after you wrote the code, the next part comes to you reading it and figure out if you missed anything. And that's again, as I mentioned, reading others' code is the most of your job and eventually reviewing. So we can look for people who can do it fast, reliably, and at scale. And that's basically the section. It's not about. So I'm really, when people call it algorithmic sections, I always cringe. Like, I mean, please don't call it algorithmic sections. It has nothing to do with it. It's logical thinking section. It's invariant-driven development section. It's code review session, whatever. But it's not about algorithms at all. That's not what we test for. The goal of this section is completely different. And so let's give some advice to you. So now we're closing up. So I'll give like 4 pieces of advice how you can improve your chances at getting through this. First of all, the first important advice is that you should master fundamentals. Do not ever focus on language syntax. Like, especially for this type of interview. I mean, in this interview, you'll get a pass if you do some syntax. I mean, it's not a disqualifying mistake if you not, because we miss syntax, compiler will catch it for you. But what's important that you master core algorithms, you know your core data structures that your language provides, and know how to use them, when to use them, know how they work, kind of basic understanding of their performance trade-offs. And because these timeless concepts like basic data structures, core things like invariants, loops, they translate across long. It doesn't matter which language you're going to be programmed next of how work changes. These core fundamentals will always matter. They will always be part of the code regardless of technology that's used to build it. So that's where most of your learning focus should come to. The second is, of course, practice problem solving. Because, again, we're looking for problem solvers. And if you don't have a practice of, like your previous job was just mundane, where you implemented some day after day, some boring, boilerplate code, and never solved a single problem in the last 2 years, then you'll be bad at it, right? That's a skill that's easy to lose. So because we're looking for problem solvers, and you'll have to practice. And you either get this practice on your job or you use aids like you go to LeetCode or Code Forces, and it doesn't directly translate into what we do for hiring, but at least that gives you some problem-solving practice, some practice to force your mind to work about the problems, and when you do this, focus on efficiency and constraints. Don't focus on just passing tests. 0 point if you go to LeetCode and just all your focus is I want to cram it to pass. That doesn't help you. Like every lead problem you solve, if you start spending your time on LeetCode, then focus on not just, whether it passes or not. Like even if it passes, think again. Maybe I could write it more efficiently. Maybe my code could have been made clearly and easier to represent the ideas. Maybe my idea was wrong, and I should have started from a different approach, and that would let me efficient. Especially in the age of AI, is becoming so much easier. Like this particular, because if you don't know, because right now you have a personal coach. If you can solve a problem or you can figure out how to solve it well, first try yourself. Because if your goal to train your mind, use AI not as a replacement for your mind. Use AI as a teaching tool that helps you build the skills, not to replace your skills. So, if you're trying to solve the problem and your solution looks ugly, go ask, AI, how could you maybe suggest me to do it cleaner and better so it's easier to understand and less chances to get wrong. And then, you don't understand why it works, again, you can ask AI to explain. So in the age of AI, you can basically, every one of you can have a personal coach that will let you get better at this. And cultivate the art of reading code. Study code. Make this conscious intent to read more code. Again, if you don't do it right now in your job. Or maybe if you're studying. Study how open source projects are built. Study how standard library of the language you're using is written. If you're working, then spend more time reading your colleagues' code, because that increases your exposure to both good and bad code, and gets you better. And that's where, even in the age of AI, where we're rapidly shifting to a world where it will write most of our code, we still have to read most of it if we want to have maintainable and production-ready code. And this skill of being able to read code and understand it is becoming even more important nowadays. And refine your communication skills, because what I often see in interviews, that person may be good technically. I mean, they can code, they can write, but they fail at basic things. They fail to explain what they're thinking about. And that's important. Again, as I told you in the beginning, what we do at Yandex is all we do is teamwork. Being able to clearly communicate what's idea and you might choose somebody else is a very important skill. And we look at your skill at that when we interview you. So find chances to write those explanations, do presentations, talk more often with other people you can find. Thinking about the better you are explaining, the better you are thinking, and that's important. So that's also a very important skill to practice. And to close up, before I answer your questions, I mean, there is some people already asked me before when I was standing there. So first of all, we don't allow AI during this session, and not planning in the near future, because again, it's not. The goal of this section is not, we're not testing how good you're at using AI. That's a different skill that's also becoming important. We're testing how good you're at logical thinking and problem solving. You specifically, not AI. So this section will likely stay AI-free for quite a while. Well, of course, as AI becoming is an important tool in software engineers' daily work, we're of course looking at experimental formats how we can test your skills at using AI, right? I mean, it's not formalized yet. It's not just, we don't have any formal standardized sections that test your skill at using AI, but we're definitely start looking more and more at people who, with pre-existing AI using skills. And so build them. I mean, if you're a software developer right now and you have not started using AI agents yet, then you're already behind. So stop whatever you're doing and start using it, start building these skills. I mean, because agents are becoming indispensable part in the software engineering toolbox, and soon every company who you go to will expect you to be already proficient with them and know how to use them. Thank you.